Okay, so I'm going to help you guys create a paper beam from an 8.5 by 11 piece of paper using Fusion, and then calculating the moment of inertia. So start a file, a design, and name it, save it, and then right away I'd like you to start a sketch. So come up here and click Create a Sketch. Pick this plane, which is the front of your cube, so this one right here. And what you're going to do is just use a line. And depending on how you folded your paper, hopefully you folded it lengthwise. So I'm assuming that, for this demonstration I just created like a fan. So if I looked at it on the end of the paper, it was just kind of a six fold, kind of like a zigzag fan, just like this. 1, 2, 3, 4, 5, 6 folds, and they're all equal in length. So I just created a zigzag line, just like this, like an accordion. I'm going to extrude this line. It has no solid, so it's just going to extrude an infinitely thin line in a moment here. And then I'm going to give it thickness when I'm done. So very easy. So if you were to fold this into a box, don't do this, but if you were to have folded it into a box, then you would just literally do that. Okay, if you were to have folded it into a cylinder, then you could probably just do a circle, and so on and so forth. So whatever your shape was, just create lines to represent the edges. Now we're going to dimension it. Okay. What I would like to do is I would like to use my dimension tool to define how long one of my folds are, and I can use some math. I know the width of my paper is 8.5 inches, so I'm going to type in 8.5, and then I'm going to use the divide key, which is the forward slash, and I'm going to put 6 because there's 6 equal segments that I've divided it by, and I'm going to press enter. So it does the math for me, and I know that it's 1.417. Now I'm going to continue to dimension each of these. I could do the math again, or I could, while this is highlighted, I could click on this dimension and it'll make it the same, and press enter. So I'm going to continue to do this and just keep touching with my left click and pressing enter each of these dimensions. If you don't have an enter key, left click and then right click your mouse and click OK is another way you can do it. Be careful that it's the dimension when you add it. I should show you this. Just there, what happened was, make sure your dimension is along the line and not the height of the line. Kind of like the hypotenuse and not the height. That's important. Okay? So I'm going to continue each of these until I get to the end. Don't worry if they're not along the same line. We'll fix that in a moment. Okay, so now I've got all 6 lengths of them dimensioned, and now I'm going to line them all up so that they're horizontal along a plane. So I'm going to come up here to my constraints tool, and then I'm going to pick horizontal. So again, depending on the shape, if I had a circle, I would just literally, if I had a circle out here, it's pretty simple. I would just define the size of the circle. I could use a ruler, or if you want to just calculate using circumference to figure out how big that diameter is, you could do that. Or I just lock the circle to the origin, is what I would do if I were you. But for this, I'm going to use constraints, and I'm going to use horizontal, and I'm going to pick the vertex, these 3 vertexes, and I'm going to pick the first one to the second one, which makes them along the same horizontal plane, and then the second one to the third one. And you'll see they all just kind of, line up with one another. So that's good enough. As long as they're laying on a flat plane, I'm fine. I'm going to finish my sketch. Don't move these now because they're not fully constrained, but for what we're doing, that's fine. So now what I want to do is I want to go to the surface bar here, or tab. So these are different from what most of you are used to. If you've never used Fusion, then it's all new, but you're going to go to Create, and you're going to go to Extrude. And then it should automatically select it. If not, pick the line, and then you're going to click this arrow and just drag it in one direction, and it's going to give you this distance. And since standard paper is 11 inches long, you're going to type in 11. And then if you want to, use your zoom down here and pan out, now you've got the whole piece of paper. The last thing we're going to do before we check our inertia is we are going to thicken the paper. Right now it's infinitely thin, so if I look at it, there's no thickness because it's a line. So I'm going to go up to Create, and I'm going to go to, where is it? Thicken. Where's my screen? I should have a screen. I'm going to pause my video temporarily. Alright, I got it. Now it's back. It's because of my multiple windows. Alright, so I extrude. No, I already extruded, sorry. I'm going to thicken. There it is. Notice how this is selected, so I'm going to pick one side. And then you have to keep clicking Select and then pick each of these. Oops, I screwed up. Cancel. Let me try that again. Thicken. Pick a side. Go back to here. Why did that not work? Try that one more time. Thicken. Oops, I picked boundary fill. Now I'm just going to click crazy. Face. Go back to select. Face. That should not happen. Maybe because chain selection is on. Oh. Make sure chain selection is not on. That's why. Okay. So as long as that's not picked, you want this to keep selecting. So turn off chain selection. And then once they're all picked, if it starts making a big blob, then that means you have a problem. Unselect chain selection. And then once you're done, a piece of paper is 0.0035. That's the thickness of a piece of paper. Hit OK. Now you have a piece of paper that's been bent, like so. Now we can check for our moments of inertia. So we're going to go up to the name of your design, right click, go to Properties, and then this window is going to appear, and go to Moments of Inertia at Center of Mass, not at the origin, or else it's going to give it to you with that little, from where the origin of your design is. You want it from the origin or the center of where your mass is. So open that little arrow, and now it gives you the moments of inertia around XX, which if you look, basically the x-axis, which is going in this direction. Let me look at it from a front view. So there's your x-axis going through the centroid, which would be probably right about there. So there's your x-axis. That's a 15.185. And then my y, which would be going, if you look at my cube, my y direction is going vertically, so through this way. So if I were to bend it, let me spin my world here. If I were to bend it like this around the axis, alright, I would have a moment of inertia of 16.742. But I'm not doing that. I'm bending it by loading my pennies and bending it like this around the x. So my moment of inertia is 15.185. That's the one that I'm concerned with. That's the one that's going to give me my my rigidity for this particular problem. Okay? Now it's hard virtually to see this, but hopefully it's helpful.